Okay, so this is section 11.2, space coordinates and vectors in space. So if you watched the last video and completed section 11.1, you should have a good understanding of vectors in the 2D sense. However, in 11.2, we're going to be looking at them in 3 dimensions, so x, y, and z. Alright, so when you're looking at these properties of vectors, you may notice that they're essentially the same as in section 11.1, and that's true in this case. Just this time it's now in space, so with x, y, and z. However, all the same properties and formulas are still utilized the exact same way. Alright, so the first example problem I did in the previous section consisted of finding the component form of a vector in 2D space. However, this time it's the same exact thing, but in 3D. So you're basically going to do the same exact thing. For the x value, q1 minus p1, y value, q2 minus p2, z value, q3 minus p3. And then for the magnitude, the exact same, and then unit vector notation, the exact same. Alright, let's keep going forward. Alright, so looking at example 4, it's asking us to determine if the following vectors are parallel to vector w. So basically all you need to do is figure out if they're proportional to one another. Or if you look above, for the exact definition, it's two non-zero vectors u and v are parallel if there's some scalar c such that u equals cv. So, as I said, basically see if they're proportional or not, and you should be good. Alright, so for example 6, standard unit vector notation, it's very simple, but I feel that I should still cover it just because of how important it is, just so whoever's reading your work will actually understand what you mean. So basically, put an I next to your x value, a j next to your y value, and a k next to your z value. And if that component is 0, just leave it blank, essentially. As you can see in solution A, v equals 4i minus 5k, which would translate to 4 for the x, 0 for the y, since there's no j, and negative 5 for the k. Alright, so if you had a good understanding of those key concepts, then you should be ready for the exercises in section 11.2. As I stated for the previous section, there isn't too much I can go in depth in, as most of the problems are solely based off of the textbook explanations. So if you have a little trouble with these textbook problems, the best thing you can do is just go back and read the textbook.